Welcome to video lesson 11.2, the extension lesson on the inverse of a function. So today we're going to be able to find inverses of relations and inverses of functions. All right. Now, just to review, a relation is something that pairs an input with an output. So basically like an ordered pair. Now an inverse relation just switches the input and the output values of the original relation. So if a relation contained the ordered pairs AB, then the inverse relation would switch the input and output and would contain the ordered pair BA. So in example 1, we want to find the inverse of each relation. All we're going to do is simply switch the inputs and the outputs of the ordered pairs and make our new ordered pairs. All right, so for the first input, the ordered pair was -4, 7, so the inverse will be 7, -4. Okay, the next one we're switching again the x's and the y's. That's all we're doing to find the inverse relation. Okay, we simply just switch the coordinates of each ordered pair. And then we find our inverse of the relation. Now in part 2, I'm going to kind of extend this page down a little bit if I can. There we go. We have a table, so it's organized in tables instead. So if they organize it in tables, then we also need to put our information in a table. Okay, may not look as nice as the one that's already there for us, because we're making it ourselves, but that's okay. So 1, 2, 4, 5, 6. There we go. Now again, we're just switching the inputs and the outputs. So the output was 5, so now that's the input, and the input becomes the output. Okay, so we're simply switching the inputs and the outputs. Okay, so in order to find the inverse of relations, we just simply switch the x and the y, the order of them. Okay, flip-flop them. Now, we're going to talk about inverses of functions. So when a relation and its inverse are functions, then they're called inverse functions. Now, the notation is a little bit strange. The inverse of a function f is written as it's f, basically. It's denoted to the -1, but that doesn't mean to the -1 power, like f over 1, okay? It just means that, so the sign of the exponent, it's just the way of writing that that's the inverse of the function. So f to the -1 of x tells us that's the inverse of the function f. Okay. Now in order to find the inverse of a function, we're going to switch the x and the y and then solve for y. So this is kind of one of the most important parts of this section. So in order to find the inverse of a function, we're going to switch the x and the y and then solve for y. So let's go ahead and try to do that. So here's our function. We're going to switch the f of x with y. Okay, so we have y equals 2x minus 5, because that's really what f of x means. Now we're going to switch the x and y. So we really have x equals 2y minus 5. And now we want to solve for y. So we're going to add 5 to each side. I'm going to kind of go over here now so I have room. So I'm left with x plus 5 equals 2y. Then I'll divide by 2 to get y by itself. So that would mean 1/2 x plus 5 halves, which is just 2.5 equals y. And I could keep that as 5 halves if I wanted. Okay. Now I need to actually write this. So instead of y, I need to replace that with the inverse function of x equals 1/2 x plus 2.5, or 2.5. All right. Now I need to graph the inverse function. So if I am graphing that, okay, what's nice is this is still a linear function. It's in slope-intercept form. So I know the y-intercept is about 2.5, and I know the slope means I'm going up 1 over 2. Okay, up 1 over 2. Or down 1, left 2. Okay, and then I can make my line You don't need to put as many points as I did, just helps to make a more accurate line. Moving on to function b. Okay. Now this function is the function when x is always going to be greater than or equal to 0. So the first thing is to replace f of x with y. Now we're going to switch x and y, and then we have to get y by itself. So we have to take the square root. Okay. So the square root of x equals y. Okay. And we're only taking the positive square root of each side because, again, x had to be the domain. And the original function here is saying that x is positive. Okay. So the inverse, the range of the inverse has to also be positive. So we need our y's to be positive, not negative. Okay. Now we're just going to rewrite the y using function notation. Sorry, -1 is what should be there. Equals the square root of x. Okay. And now when we graph that, remember how to graph the square roots? We could make an xy table. Okay, if we wanted, when x is 1, the square root of 1 is 1. When x is 4, the square root of 1, or the square root of 4 is 2. And when x would be 9, we're going to run out of room, but that would be 3. So, and when x is 0, it's 0. So we have 0, 0, 1, 1, and then 2, 3, 4 will be 2, and 9 will be 3. Okay. That's our inverse function. The original function, okay, f of x, would have went x squared, so it would have been 0, 0, 1, 1, 2, 4, okay, 2, 4, sorry, 4, 3, 9. Okay, so the original function would have been something like that. Okay, so this was f of x, and this is the graph of the inverse of x. Okay, I'm just showing that. It just asks you to graph the inverse function, so you only would have to graph the inverse, just like we did in part A. It just helps to sort of see there just should be complete opposites. The x and y's are just flip-flopped for inverse. All right. Now you have a couple practice problems. So what you're going to do for 1 and 2 is just simply find the inverse of the relation. Again, that's just changing the x and the y, okay, or the input and the outputs, switching them. Number 3 asks a question about the domain and range of a relation compared to the domain and range of the inverse relation, and explaining that. And 4 and 5 ask you to find the inverse of the functions and then to graph them. Okay, again, just graph the inverse function. If you have any questions, make sure you write them down and ask them during our next class. I'll be happy to help you. Have a great day. Thank you.